In this video, we will learn how to call the custom IP in our project and use it. So to do that, I would go and create a new project. Uh, I would call it calling custom IP. Then we will go ahead and just create a blank project with basis 3 as a board. Once we are here, um, now this IP catalog thing I would explain you. This is a blank project. I would go and open the create block design under IP integration, and I would name it anything, but for now let's say RC8 or just RCA. Now this is a blank canvas where you can create block designs of IPs and connect them using GUI, but you can also do that same using command here. In the TCL console you can give commands which will do the same, which you can also do using GUI, but in this video we will go with GUI one. So I would go ahead and wants to add the ripple carry header which we made an IP, but it's not present here. The reason being is we didn't add that custom IP to our project. So I would go to project manager, and in setting I would go with IP. uh, but I'm using 2023 version, but the earlier versions have different um, UI, but the addresses are same. You will find the setting in project manager, maybe from here or maybe from the site itself. In the setting, the setting won't look like this. It might be different, but in IP section, go to the repository tab and you will see the same window. So in this, add the directory where we stored the IP. I told you this is very important because that would be the same directory we have to mention when we want to call that IP. So once I mention this IP, directory location of IP, it will look for the IPs in that directory. So one repository was added. In that repository, you can see this one IP, which is Ripple Carrier. So now I would go and call it from the catalog. This is the catalog. There are pre-built uh, pre-built IPs already present here, which are mostly made by Xilinx. So I would call the Ripple carry header, and this is the Ripple carry header. I made a little bit changes in this. There's no scene here. Earlier there was scene, but it's not present now. So this is the uh, simple IP block. I'm planning to make an advanced IP block like this adder one, where we can have multiple inputs, and we can also disable these multiple inputs. Not only we can have this, we can also make changes to this, but now we are sticking with a more simple one. So regarding this block, you can see this is the name of the block, version 1.0, and this is the name of the instantiation. You can't change the name of the block unless you change the IP name, but you can change the instantiation name. uh, let's say adder one. So we can also go and customize this block under this customize block setting. These are the options in 2023. Maybe it's different, but the UI is different, but the options are on this side. In the earlier versions, you can click on it and you can mention the input width. If the input is 8, it would 7 down to 0, but the sum is uh, 1 bit more than the input because it carries the carry in itself. So I would go and call another IP, same the people, and it would instantiate uh, with the same numerology. But I want to delete this, and I will copy this. The benefit of copying this, the instantiation name would, the Xilinx is smart enough to instantiate it with the same name. Uh, Here I used adder one, but the Xilinx would say, oh, this is the one. I would like increment it by one and use the same name. So that's why it's better to use the instantiation from the same block. Like you can click on it and right click to copy it, or otherwise you can choose the shortcut. So now I want to create 4 input and 2 output. So I would go and connect this, hover over the port. You can see the symbol, pencil like symbol, and left click on it, and you can drag a wire, and it will tell you which ports can accept that. So you can't give output to the output, okay? You can give the out some data out to data in. So I connect this to this and this to this. And there's another thing I would like to mention, that you can make this port, you can make this connection to external port, like we do in uh, schematics. You can go ahead and click on make external. So when you make this external, this is the pin. You can also change the name to just A. So click on it and use the shortcut Control T. Then this is it. You can change the instantiation name again. Control T. Control T. So these are our 4 8-bit numbers A, B, C, D, and the output is 8-bit. Now watch closely. The here the output is 9 bits, right? But the input is 8-bit. Let me make this also external. So um, I was talking about this pin. You can pin this. Now you cannot move this. Sorry, I don't know what pin does then. Maybe it will, well, the blocks to the location. That's what I did, right? Anyways, forget about the pin. This is the regenerate layout. It will beautify the appearance, but we actually pinned it, right? We unpin it and regenerate the layout. So it will beautifully rearrange the blocks and pins. Then I would go and validate the design. So there are no critical errors for some reason, but it should show some error for this. Anyways, you should be careful about connecting this because it's giving 9-bit. So I would make the changes to 9, input with 9. So I get the matching here. So this is my 4 8-bit input and the 9-bit output. It should update. So now I can validate the design. It will look if there's a input is of same width or or there's an error in connecting uh, the port. Maybe the port has not been, let's say if we remove this and we try to validate it, it's validate. I don't know, it shouldn't, but it's doing it for some reason. So this is how you create the block diagram, and I would go ahead and generate block design. I don't know much about this, but out of context per IP localhost. Anyways, it will generate the Verilog code for the block diagram you created. This takes some time. If we go and get the, it's using 100% CPU and 10 GB RAM, and it's also using my graphic card for some reason. Okay, so now if I go to the sources, I can see this a design which has instantiated three blocks of IP, and this is the Verilog code. We can also go ahead and simulate it. You have to give the name RCA. Once simulated, I would restart it and I would post constant. You can also write Verilog code for it, like test bench actually. You can, for now I would post constants. So this is the sum, 4 plus 3 plus 2 plus 1, 10. So this is an uh, unsigned adder. You can also make signed adder. This is it for, we created IP, we called it, we generated we generated we generated this block design into Verilog code. We also simulated it. This is the Verilog code. This is instantiating the blocks three times, and this automatically takes the wires, and this is it. IPs are good to hide the logic. There's no logic. We cannot look at the logic inside it. It's a good way to hide your logic inside it. So we now we can see the logic, but there's an option you can hide the logic. So all things that the user can see is the inputs. He cannot see how the logic is implemented. You can just say it's an adder. He cannot even know it's a ripple carry adder. So that's how the IPs are used. It and if you create a good IP, you can earn royalty from that company who is using your IP. So this is it. Thank you.